be together tonight. We're grateful for the opportunity to be in BYU in this moment, because we are learning about mathematics in this moment. Father, we ask you to bless Jennifer so that she can be good in this moment, and please bless the Hannah's family and my family also. Father, we ask you to help us to understand the topics of this class through the Spirit, and please help us to apply the knowledge we have acquired through the reading. Father, we love you and we say these things in the name of Jesus Christ. Amen.
Amen. So did you have any questions for the part 2 preparation part?
No, I read that we must solve that part in this meeting. I don't know if I am okay, but in fact, I gave the solution for that part also.
Yeah,
So,
I also solved it because it was part 2. But I didn't have any questions. So.
okay, perfect. Okay. Dun, dun. Information. For the next 9 questions, we will review the PTC testing study with different data. Out of 70 females in the samples, 52 can test PTC. Out of 59 males in the sample, 42 can test PTC. Please use the data presented here. Can test PTC? No, yes, or in total. Female, 18, 52 equals 70. Male, 17, 42 equals 99. Total 35, 94 equals 129. Let P1 be the proportion of females in the population who can test the PTC, and let P2 be the proportion of males in the population who can test the PTC. The research question for this study is given here. Is the proportion of females who can test the PTC different from the proportion of males who can test PTC? Question 3. Use the data in the table to find P1. Okay, P1, so is x1 divided in 1, right? 1. Let P1 the proportion of females who can test PPC. Okay, it is 52 divided 70 equals 0.743.
Yep. That's what I got. So question 4. Use the data in the table to find P2. So that would be 42 divided by 59, and I got 0.712.
Yeah, I got the same. Okay. Which type of hypothesis is appropriate for addressing the research question? Okay, you know, P1 equals P2 and is the proportion of females who can test the PTC different from the proportion of males? Oh, I think in this case is the B, P1 equals P2 and proportion 1 different to proportion 2. What do you think?
I think it's A, just because they both say the same thing except for one's P hat.
Yeah. Yeah. Okay. Thank you.
You're welcome. So create a 95% confidence interval for P1 minus P2. Input your answers for the point estimate, margin of error, lower bound, and upper bound. What is the point estimate for this 95% confidence interval? So that would be p hat 1 minus p hat 2, and I got 0.031.
In this case, we must use the equation of the confidence interval. So it is P1 minus P2, P hat minus C times square root of P1 or which equation are you using?
So the confidence interval, it's always your point estimate plus or minus your margin of error. That's what it said in like chapter 4 or something like that. And so anyway, the p hat 1 minus p hat 2, that's before the plus and minus, and so that's your point estimate. And then everything after that plus and minus is your margin of error.
Okay, for something here.
You're welcome.
We have one, so we have one is 0.743. And you will write to this is equal to 0.031. Okay, thank you. So let me put it here. So this is the formula for point estimate. And here is the margin of error. Okay, cool. Thank you.
Yep.
So in this case, as you said, to calculate the margin of error is C times a square root of P1 or all the information, including the formula for the point estimate.
Just the z star square root of p1 and all that stuff. That would be the margin of error.
Okay. So this Z is so in this case is 1.96 times square root of P1. P1 portion who can test. 52. 0.743 times 1 minus divided 70. So that is 0.0272 y 142.8. por 1.96. So I got, in this case, 0.102.
I got 0.154.
So in this case, you got 1.96 times the square root of 0.743 times 1 minus 0.743 divided 70.
Yeah. And then plus 0.712, 1 minus 0.712.
Okay, I have a problem here. Yeah, thank you.
Yep.
So 0.154.
Yes. That's exactly what I got.
Thank you. So in this case, the lower bound would be the point estimate plus this result, right?
Lower bound would be minus. For upper bound, it would be plus.
Yeah. So 0.031 less 0.5 minus 0.123.
I got 0.079. Oh, you know what? I just realized I put in the wrong answer. So yes, it would be negative 0.0123.
Okay, thank you.
So for the upper bound, I got 0.185.
Zero 0.185.
Yep.
Okay. Okay. Question 10. With alpha equals 0.05, what decision do you make? In this case, I don't know how to answer this question.
Okay, so for this part, I had to use the Excel worksheet, the categorical data analysis. And if you go to two proportions and you plug in your x1 values, n1, x2, and n2, then you get the p-value, which is 0.693, which would be greater than the level of significance, so we would fail to reject the null hypothesis, the first one.
Okay.
Question 11. Which of the following statements best describes the outcome of this study? I got D. There is insufficient evidence to suggest that the true proportion of females who can taste PTC is different from the true proportion of males who can taste PTC.
Yeah, I get the same.
Okay, good.
Information. For the next 9 questions, we will review the mortality rates and day of admission heart attacks, a study with different data. Out of 180,519 who had a heart attack during a weekday, 60,713 had died. Out of 42,447 that had a heart attack on the weekend, 6,155 had died. Please use the data presented here. Heart attack outcomes, diet, survived, total, weekday, group 1, weekend, group 2, Let B1 be the proportion of patients who had a heart attack and were admitted on a weekday who died, and let B2 be the proportion of patients who had a heart attack and were admitted on a weekend who died. The research question for this study is given here. Is the proportion of patients who had a heart attack and are admitted to the hospital on a weekday who died less than the proportion of patients who have a heart attack and are admitted to the hospital on the weekend who die? Use a significance level of alpha equals 0.05. Question 12. The conditions for conducting a hypothesis test are satisfied. In this case, okay, wait a moment, please. I am going to open the door. Okay. So in this case, we must use the N1 times P1 bigger than 10?
Yeah.
Okay, perfect. Okay, so in this case is 1. In this case, we use P1 or P-1.
We use P hat. P hat 1.
P-hat.
Yeah.
So in this case, we use P-hat 1 as as X. Or no?
To find P hat, you need X.
So in the formula, we must replace the value of N to obtain the P, right? Or the other way.
So it's what I have in my notes is that it is N1 times P hat 1.
Yeah.
p hat 1, you gotta take x1, divide that by n1, and that will give you your p hat.
Oh, yeah. Thank you.
Dígale a la mamá que tuvo la vez que estuvo de traer el agua al papá. ¿Viste eso? Mamá, míreme allá adelante. Que estuvo antes de traer el agua al niñito. Nadie entonces ni tuvo el niñito llevó esa agua. Solo yo que están pendientes de guardar el agua con el niñito. Sí, solo yo. Vamos, vamos, mijo, que estamos haciendo el trabajo. Vamos.
So in this case is improvisation minus por 1 menos 0.141 10 0.141 por
Hey guys,
Hey, Daniel.
sorry about the I was traveling. So what question are we on?
We're on question number 12.
Okay, got that the conditions for conditional hypothesis test are satisfied.
That's what I got as well.
Hi, Daniel. How are you doing, my friend?
Good. Getting over a cold. Cough.
Okay.
So we got true for that one, right?
Yeah. Yeah.
I got that one.
Okay. So, number 13. Which set of hypotheses is appropriate for addressing the research question? Less case. So that would be the last one. Null hypothesis, P1 equals P2, and the alternative hypothesis is P1 is less than P2.
So tail to the left, right?
Yeah, the tail would be to the left.
Patients have heart attack are immediately less than the proportion of patients. Okay. The proportion of patients who had a heart attack a weekly. A weekly is less than P2. Yeah, and that is what I got. Okay, in this case, question 14. Is the data in the table to find P1? We had one. I got 0.141.
That's what I got. Yeah. So I took 52, divided that by 70. 8 points.
7.
Or wrong question. Sorry. Go ahead.
Oh. So use the data in the table to find P2. I got 0.145.
Yeah, I got the same.
Yeah, I did.
Okay, in this case, so for two proportions, x1
Like save like 20 times for these questions.
Sorry, what was that?
Were we trying to figure which one out? 17? Or I started
Um,
mumbling.
I think we're on 16 right now.
Yeah.
Yeah.
Negative 2.020.
Yeah, I got that.
I got that as well. So question 17. Give the z-score from the last question. Which should you shade, the left or the right of the z-score for the p-value? To the left.
I'll agree.
Okay. Question 18. What is the p-value for this test? I got 0.022.
Me too.
Same.
So, question 19. What is the decision for this test? Yeah, the null hypothesis.
Yep, that's what I got.
Same. I reject the null hypothesis as well.
Okay. That's good.
Which of the following best summarizes the conclusion of this test? I chose C. There's sufficient evidence to conclude. So when I have a question on this, because I kind of guessed.
Okay.
So when we're like trying to figure out the actual sentence, if we're rejecting the null hypothesis, it's always there's sufficient evidence.
Yes.
And from what I've understood, and so when we have on a weekday who die is less than the proportion. So on that part, do we talk about the alternative hypothesis, or do we jump back to the null hypothesis and talk about that?
You always do the alternative hypothesis.
Alternative.
Yeah.
Okay.
Yep.
I think there was another one, no, like that in the quiz somewhere.
We did one earlier.
Yeah.
Like number 11?
Yeah, 11. So I missed 11, 10, and 9, or 11, 10, and then 7 and 6. So what was the point estimate in this lesson 18?
Okay. So the point estimate, we got 0.031, and we got that from the confidence intervals. Do you remember reading about the equation in the chapter?
Is that the one where it has like the square root of like 1 minus p star? It's that really long equation?
Yeah.
Okay, yeah, I went over it.
Okay.
And you guys found the confidence interval.
Yeah.
And then from that, how did you guys find the point estimate?
So the point estimate, you got the plus and minus in the middle between the point estimate and the margin of error. On the left side, you have the point estimate, which is p hat 1 minus p hat 2. And then on the other side, you have the margin of error, which is the z star square root of p1 hat, and it's really long.
Okay, so for the margin of error, you can't just take the upper minus the lower divided by 2 and get the margin of error.
Actually, you can. You get the same answer.
Okay, because I did that and I got 0.031. And I was like, I know I'm going to get this wrong. I'm going to ask them. I'll mess with it a little bit more. I'll work through. I'll carry on. So thanks for that. I'll take it from there.
Yeah.
So that takes out 6 and 7, and then 10. So I'll figure that out from my question earlier. Once I have those other two, I'll get these. But thank you.
Yeah. No problem.
Okay,
Yeah.
thank you.
All right. You can go ahead, Christian.
No, I was telling you thank you.
Oh.
Because
Yeah, I had a go ahead.
I was just going to say we can move on, but if you have something to say, go ahead.
Oh yeah, it was about the project. Now, do all 4 of us or everyone in the group need to submit the actual design, the document that you sent to us? Like, are we supposed to make corrections as well, or is that just you?
No, so in this case, it was just me who submitted it because I was in charge. We assigned you to one of the weeks. I don't remember which one.
Inference and take action.
Yeah.
We've-
So basically, you'll be in charge of like typing that down, and you'll give us assignments based on what is needed and what we can do if we need to, and then you'll be the one to submit that one. So I submitted this one, and
that covers everyone.
yeah, that
right?
covers everyone. But everybody had to submit the quiz.
Right. I think I did that. And we're not using any human subjects or any like surveys or anything like that.
No, we're not.
We're
Don't
not.
have to worry about that.
Then I think I should be okay after figuring these out.
Okay.
Alrighty.
I think we only need to have more information of Jennifer about the way that the information will be collected to correct the first part. But we're okay with this.
Yeah,
How are we getting the water bottles?
So
Who's doing that? Who's collecting the data?
So Jennifer, she works at a school, and anyway, she can get a hold of water bottles for free because they have them up there like at vending machines or something. So anyway, she can weigh them and then just put them back. And so just Jennifer will be weighing them to collect the data.
Oh, she's gonna weigh.
Yeah.
She's not gonna empty the water bottle.
Okay.
Different brands or one brand?
We're doing just one brand.
Brand. Okay.
Yeah. Any other questions?
No, I am with this. I think we are going to work on the project on Thursday, right?
Yeah.
Okay, wonderful.
What day is that? What day is first day?
Thursday's the 15th.
Oh, Thursday. I thought he said the first day. Alrighty.
Okay. So, do you guys mind if I close with a word of prayer?
Yep.
Okay. Dear Heavenly Father, we're grateful that we were able to have this meeting and that we've been able to be gathered together and that we were able to learn and teach one another. And we're grateful that we were able to be here. And we ask you to please bless Jennifer and her family. They'll be able to prosper and be able to, that Jennifer will be able to make it next time. And we're grateful that Daniel, Christian, and I were able to make it this day and that we've been able to communicate. And we say these things in Jesus Christ. Amen.
Amen. Thank you.